Oh, this is going to get really in the weeds really quickly.
This is like smart contract designed by people who grew up writing React.
Unfortunately, quite accurate for me. It gets actually so much more deep than that.
The White House tweeted that horse.
What? Welcome to the Coinbase Developer Podcast, a technical deep dive with top on-chain builders in crypto and beyond, walking through real architectures, code decisions, and the lessons learned scaling in production. My name is Yuga Cohler, and I'm an engineering lead here on Coinbase Developer Platform. And I'm here with Erik Reppel, Head of Engineering at CDP. How you doing, Erik?
Good, Yuga. Excited to chat today.
Likewise. So I was just reflecting on the word coin, which holds a lot of significance to both of us. Coinbase, obviously, and also coin is the ticker of Coinbase, the stock. But I feel like we have a guest today who's very familiar with the word coin and has started a revolution around it.
Yeah, it's coin is common in Tyson's life to a great depth. Tyson's ex-Coinbase as well, and I think we're going to talk about the new Zora coining mechanism today, Tyson.
Yeah, sweet. That should be fun.
Awesome. So we've got Tyson Battistella, the co-founder and CTO of Zora, here today, who's going to be talking about how he shifted the meta from minting things to coining things. So Tyson, super excited to talk to you today. Maybe we just start diving in here. What are Zora coins? What does it use under the hood? Tell us all about it.
Yeah, for sure. I think, I'll start by describing kind of like what Zora is. I feel like it'll be useful to get a bit of a background. We've been doing this for about 5 years now and it's shifted. But I think the overall hypothesis that we've had at Zora for the last 5 years is that we see every piece of internet content as something that's inherently valuable. And what often happens is social media models tend to fail creators in the sense that this content that they generate has enormous attention and value, but is rarely ever captured by any of the creators. So our solution is a social marketplace. And what that means is we have these open permissionless markets that are designed specifically to reveal and monetize the latent value of content. So anyone can kind of trade on the attention that's generated by content, and that directly rewards the creators and the distributors who help kind of make that happen. So kind of more simply put, we're helping to try to turn the attention that's generated by content into an asset, and that kind of forms this open infrastructure for any people to build and interact with that content.
Awesome. So Zora's a platform, and Erik, you used to work at Zora too, right?
Yeah, I used to report to Tyson at Zora, actually, as the head of engineering for Zora. This is like Tyson's very right curve way of saying meme coin's good. So I'd love Tyson to, I actually don't know how the new coins mechanism works. It was one of the first things you guys developed after I left. I'd love to hear, how does it work? What do the contracts look like? How is it different than the minting mechanisms at the technical level?
It is very, very straightforward under the hood. So all we have effectively done is for every piece of content that's created on Zora, we deploy an ERC20 token that represents that content. What that means is we have quite literally a factory that deploys ERC20 tokens and deploys those tokens onto Uniswap. So if you go as a creator onto Zora and create a post, whether that's like an image or a video or a piece of music, we create an ERC20 token with a supply of 1 billion tokens. We give you 1% of that token, and then we deploy that token onto Uniswap V3 pool. And what's really powerful there is because these things are ERC20 tokens, there's a decade of existing infrastructure that we're able to leverage to kind of create these open marketplaces. It is very, very simple under the hood. We do a lot of fun things with the liquidity provider, math under the hood on the Uniswap curves, but for the most part, it is a very simple concept. It's really just creating these open markets for the content by attaching the content to a piece of to an ERC20.
And what was the motivation there? Because generally when we think about creation and creators, we think about works of art, which have traditionally been represented on chain via standards like ERC 721, essentially non-fungible tokens. But what was the insight that led you to use fungible token standards to represent these pieces of content?
Yeah, and we originally had ERC 721s or non-fungible tokens as the underlying mechanism on Zora. And the idea there was, you have an NFT, which is effectively a pointer to some piece of content, and that NFT can be owned by one person. But that was actually the very crux of the issue for us. We saw that with these ERC 721s, they're effectively meant to really allow ownership of unique assets for an individual or one individual at a time. And that meant that it was great if you had some scarce piece of media or some scarce information that had to be represented in a one-of-one instance. But for content on the internet, we know that that gets distributed extremely far and extremely wide, and it's much more likely that there are hundreds or thousands or millions of people that are interacting with this piece of content and would actually want some ownership or some ability to play with it on chain. So when we had non-fungible tokens, I think a large kind of learning for us was the fact that you really only allow a limited set of people to interact with that token. ERC20 tokens being not infinitely divisible, but like largely divisible, really allow thousands and thousands of people to be able to interact with this content. So that was like one of the big learnings for us over the last few years, is switching from non-fungible goods to the fact that content itself is actually fungible, and it's very nice to be able to allow multiple people to interact with tokens at once.
And you guys went through 1155 to eventually land on ERC20s, right? And like 1155 is like the token standard that allows for, it's kind of like a hybrid between an ERC20 and a 721, where like the analogy I'd make is like ERC 1155 is like RuneScape gold, where like all gold is the same, but you have like 100 gold. Whereas like ERC 721 is more like the party hat, where you like have a party hat, but you don't have a balance of party hats. And so like
Definitely.
what like led you to go from 1155 to 20?
The switch that we made from 721 to 1155 was very much that learning that I just mentioned, where we realized that many people did actually want to participate in these markets instead of one particular person being the owner of an asset. I think 1155 was actually a bit of a half step for us, where it was the closest thing that felt like a 721 to us. So it was like the next logical step for us to jump into. But looking back on it, I think we are actually really just moving towards ERC20 this entire time. And the reason for that, purely from an infrastructure standpoint, was that ERC20s have this decade of infrastructure built on them that allow us to plug into all sorts of new ecosystems that have existed forever. Whereas 1155s were a little bit esoteric in the sense that they were really formed, not really formed, but they were used more recently and had significantly less background or infrastructure for us to build on generally. So we found that for a lot of the market infrastructure, for example, with 1155s, we had to build a lot of that from scratch. With the ERC20s, we have all of the superpowers of the entire Ethereum and Base ecosystem that we're able to leverage whenever we want.
Can you speak a little more concretely to that, of like these pieces of infrastructure that are standardized around ERC20? I assume these are like plug and play pieces of code, could be SDKs, could be libraries, but could also be sort of on-chain smart contracts you can interoperate with. Could you kind of just describe that infrastructural ecosystem for us?
For us, obviously, one of the biggest ones is Uniswap itself, which is effectively the everything exchange, which allows you to swap any asset to any other asset with some very smart routing. That is a very, very powerful and critical piece of infrastructure that we use to form these markets for millions and millions of tokens. We also have just the fact that we are using ERC20's support in every single wallet application that's been built over the last decade. Most of these wallets know how to handle ERC20s because they've been around for so long. Generally speaking, the fact that the ERC20 standard is so much more, I'll call it simple, makes it very easy for anyone else to be able to build on top of it. ERC 721s and ERC 1155s are, I wouldn't say complex, but definitely more large for integration's sake, when we have so much ERC20s that have already existed and have been built around for so long.
Well, one, it made me kind of sad that when you said ERC20s have been around for a decade, but I think you're right. I think they have been around for a decade. So time's flying. We're getting old. But it's kind of like, in a way, it's kind of sad to me that we have to rely on these like old standards for compatibility. And I'm curious because Zora still, a lot of what brings the value to that art is like the metadata and the imagery and like all the like associated properties of it, which is really well articulated on how to define that with a 1155 and a ERC 721. Like, how did you get around that with 20? Like, there's not usually art that's associated with a ERC20.
Yeah, and I actually think that's why we jumped into 721s and 1155 so quickly, was this idea of like, oh, well, the metadata has to be in the standard of the token that we're using or else it doesn't really exist. But the reality was there actually is an EIP that supports metadata for any token type, and in fact, any contract type. That's EIP 7572, I think. That standard is actually really powerful because it allows any contract that's deployed on Ethereum to have metadata, and that metadata shape is the exact same as ERC 721s or ERC 1155s. So even though conceptually we're used to this idea of 721s or 1155s being the only thing with metadata, there is actually an EIP that exists for any token type or any contract type to have its own metadata. And I actually think this EIP is very powerful because it would allow contracts that aren't tokens per se, but maybe entire apps to have their own metadata. So you could have a very, very flexible metadata standard for any type of contract on Ethereum. And it didn't have to be a 721 or an 1155 to attach metadata.
To be clear, do the Zora coins implement the standard?
They do, yeah.
They do. Okay, so that's how you actually link the off-chain work of art or the post on Zora to the actual token itself.
Exactly. And we've seen some really great builders play with this standard for us. So they have Ripe is one of our creators on Zora who's built this very, very fun token on Zora that is a picture of the Mona Lisa, but every buy or sell on chain actually updates the metadata and puts a plus or a minus on the painting. So what ended up happening is obviously over time that painting kind of just became a black portrait that was the Mona Lisa, as these pluses and minuses were kind of overlaid on it. But because this metadata standard can just be updated by the owner at any time, they were able to build this very, very cool kind of addition to Zora or extension of Zora. Cool. So this right here, this is the piece. It's called Liquidity Layer. This originally was a picture of the Mona Lisa, but if we kind of zoom in, you can see there are pluses and minuses that have kind of been overlaid with every single trade that's happened. If we go through the activity, every buy or sell transaction has actually been adding a plus or a minus to this piece. And if we go look at it on something like Basecamp, for example, if we actually look at the token contract, we can see that the events that have come out of it are contract metadata updates. Now, this is going to be very hard to find because every single buy or sell has happened. And actually, I don't think I will find it. But within this contract, there is events of the contract metadata URL being updated that we can index and build on top of. My favorite things about building with these open protocols or these open standards is the fact that people get really creative very quickly on what's possible. And the extensions that we see get formed on top of Zora being kind of open and permissionless is always fun to watch for us.
For a developer, like Zora is sort of, it's a product, of course, but it is also sort of like a platform for these creators. And so when you came out with coins, to what extent did you not just provide like the new platform for deploying the contracts based on the content, but also like a set of use cases or set of SDKs or set of like ecosystem around it? So like that example of like adding metadata every time there's a buy or sell, was that something that someone just came up with organically, or like do you do any seeding of ideas to that extent?
That was purely organic, that one, which is part of why I think I love it so much. We do have, it was actually just released last week, we do have our own SDK for people to build things like that on top of it. I'll actually share that here as well. Yeah, just at docs.zora.co, we've actually opened up the SDK for anyone to be able to create coins, display coins, dig into the contracts themselves, and like what Wipe did, start playing with the metadata as well. So we have tried to make it as easy as possible to build on, and I think we're very fortunate to be able to do this because of everything being so open. There's no permission or like API keys required for this.
That composability really is like the, I think, hidden superpower of crypto that people who aren't in crypto don't quite fathom. Because like the EVM and, you know, blockchains more generally, like you do just get so much stuff for free, and like it's all these standards that are open, and you can just like compose these things in a way that is like unintuitive if you're coming from like a Web 2 world. Was there like a
100%.
moment where you, in your career, was there like a moment where you realized like, oh, this is like, these are just little Lego bricks that you can kind of glue together in arbitrary forms?
Yeah, definitely. I actually remember it pretty distinctly. There's actually a conversation I was having with you, Eric. In addition to Eric and I working together, we also went to college together. I remember we were talking about Ethereum in some club outside of class, but I distinctly remember this like realization that because everything was so open and public on Ethereum, it was effectively similar to a chessboard where you can see everything that's happening all at once. And because you have the visibility into everything that's happening everywhere, the stakes or like the game theory that you can start to do is open, and there's no hidden cards or no hidden plays happening. You just see exactly what's happening on chain and you can build on top of that however you want, and then everyone can see you building on top of that as well. Obviously that's changed quite a bit with a lot of these ZK rollups and ZK generally, but this concept of like truly having open data everywhere was something that was really, really exciting to me and something that I wanted to dig into a lot further.
In that analogy, like the thing that's cool is anyone can play a move with their pieces. Like it's like an open chessboard where like it's not just two people, you're watching two people play a game. It's like anyone can just start playing the game.
Exactly. It was definitely the thing that kind of sold me into crypto and kind of what has kept me in it, I guess, for now, unfortunately, a decade. Yeah, it's been a long time.
And so you mentioned like all these coins are being deployed on Uniswap as fungible tokens. Can you talk a little bit about like in the weeds mechanics of like how liquidity is bootstrap? What kinds of pools are these? Are there LPs? Yeah, how does all of that work?
This might get very deep in the weeds. I don't know if anyone's played with Uniswap math, but it gets intense pretty quickly. But I can dig through the code and we can kind of walk through. What might be useful is us hopping into Figma at some point, but we'll start with the code and see where we end up.
I'm also curious why you went V3 instead of V4 on Uniswap.
I mean, very, very openly, we are planning on going to V4 as well. I think we stuck with V3 because we knew it would be well supported within Uniswap's UI in addition to our own. And while we were building our transition to coins, V4 hadn't officially been released yet. So we knew that we would have application support across every interface, not just on the Zora UI. If we had done the Uniswap V4 route, we had this risk of really Zora being the only distribution center. And one of the superpowers, like we just talked about, was the fact that you can have multiple platforms building on top of this, not just one.
It always takes a minute for standards to propagate.
Exactly. Yeah. This is the coin contract. It's very, very simple. It really is just an ERC20. We have a few things, obviously, with our upgrades and some constant files, but really there's nothing too special here. Most of the magic actually happens when the token gets deployed. So all of this, all very straightforward, nothing too special here. We have a few things around platform rewards. So anyone who's building on top of Zora can obviously tap into the volume and the capital that flows through the Zora protocol. But the Uniswap action actually happens right here in this deploy liquidity step. So like I mentioned, 1 billion tokens gets deployed, 1% gets sent to the creator. That was actually up in the initialize function. And then the remainder gets deployed into Uniswap pools. So what happens here is we have this function called set up a pool. Set up a pool, I'll go to the V3 version here. Well, actually, I'll start with the most simple version, which is our legacy version. All that we really do is we take our token and we deploy what's called a full range position on Uniswap. And that means that we take all of the tokens, so 990 million tokens, and deploy them from price 0 to price infinity across the full range of Uniswap. Oh, this is going to get really in the weeds really quickly. There's a set of what are called ticks along a curve, and each tick represents 0.0001% price increase of a asset. So you go from 0 to 100, and there's all of these ticks that exist. What ends up happening is if you deploy liquidity uniformly across every single tick, you end up with this very nice bonding curve that I think people have seen a lot of images of by now, where price kind of exponentially increases over time. That is like how Uniswap v2 works, and that's how Uniswap v3 works in the most simple form. But what Uniswap v3 really introduced is this concept of ticks and deploying concentrated liquidity within specific ticks. So our legacy setup was just the most simple Uniswap v2 style. We deploy liquidity across the full range and allow tokens to move up and down that curve. What we've done with our newest version is we use something called concentrated liquidity, and we worked really closely with Whetstone Research on this. That's Austin Adams and Doppler. I don't know if anyone's heard of Doppler, but it's a very, very fun project. That's like
I saw the tweet today.
Yeah, exactly. Yeah. And that's where things get like quite intense quite quickly. So rather than us deploy across the entire range of pools, what we've done is at the very beginning of a curve, we concentrate all of our liquidity across like a log normal distribution. And what that does is it allows us to drastically reduce the initial market cap of a token, while kind of protecting users against snipers that can snipe very low value tokens very quickly. So all we really do is we take all of the 990 million tokens, we calculate a log normal distribution, which basically says, given these 990 million tokens, calculate the tick spacing that we deploy all of our liquidity at. And a log normal curve is really just like a normal distribution on a log scale. So all we're really doing is like concentrating liquidity on this log scale. And what that really helps with is the price discovery at the very beginning of a token. Rather than have a whole bunch of tokens be extremely cheap at the very beginning, very few tokens are very cheap at the beginning. And as more tokens are bought, the price increases such that you can't snipe a whole bunch of tokens very quickly for very cheap. I'm so afraid of going too deep in the weeds with this, but I'll keep diving in. Really what happens is we have this is where I wish I had Figma to draw this out. We have a log normal distribution at the very beginning of the curve, which means we have a lot of concentrated liquidity at the very beginning of the curve, which helps make sure that tokens aren't super cheap at the beginning of the deployment. After that happens, we just have a regular Uniswap curve for the rest of the ticks. But we have built this with Whetstone specifically, and I want to make sure that Whetstone gets shouted out because they really helped us with the math here. We built this so we have this really, really powerful concentrated liquidity mechanism at the beginning that makes sure tokens can't get sniped for too cheap, and also that the price discovery action happens very early, so we have smooth operating curves and not a lot of loss at the very beginning of our curves.
So in Uniswap v2, the price curve is explicit, or I guess depending on your viewpoint, it's implicit, where the curve of price is related to the x times y equals k constant product formula. And so that curve is like, it just exists in the math. And then with ticks in Uniswap v3, each tick is like formally represented as like two numbers or one number that represent the different spacing of liquidity. And what that lets you to do is deploy liquidity to a specific segment of that like x times y equals k curve. And so you can choose where you deploy the liquidity as the person deploying. And so with coins, what you do is you take the supply of coins that are created when a piece of content is coined, and then you give some of the liquidity to the creator, and then you put the rest of the liquidity into a strategically selected tick space such that it creates like good pricing dynamics early and prevents sniping and has like all these like mathematical properties of a good market that you want.
Exactly. That was so much more succinctly than I was putting it. Thank you for that. Yeah, exactly. And that's very, very powerful. And that's one of the reasons that I was like kind of excited by V3 is the fact that you can get much more specific about liquidity strategies, and you don't need to be as naive about supporting an entire range of motion for an asset, because realistically that's quite inefficient, especially for tokens that we want to be very low starting market caps so we can have real price discovery on them.
And so the 99% of the liquidity that gets deployed to the Uniswap pool, is that belong to no one basically? And like when people trade on it, does anybody get LP fees?
Yeah, so the LP fee is actually still owned by the creator, but it's locked in the token itself. So what that means is any fees that happen on that LP position are sent to the token that was deployed by the creator and then distributed to the creator as a protocol reward. And that's something that we've had for quite a while at Zora, where creators are always receiving the trading fees on the token that they've created.
That means that like your ERC20 actually has like another standard for holding these rewards, and then you distribute directly out of the token.
That's right. Yeah. So I'll go back up to the initialize function of our token where we set up these pools. And we can see here, we do all of our regular ERC20 setup, and then we mint all of the tokens. We transfer the tokens to the creator, that 1%, and then we deploy the liquidity. Once we've deployed the liquidity, so we've done this calculation of all of the positions and the concentrated liquidity ticks that we need to do, we mint these positions onto the Uniswap v3 pool. This mint function returns a set of ERC 721s representing the liquidity positions you've created. And those 721s are stored on the token contract itself.
You showed us like calculating the log normal distribution. That's like what that array of LP positions is. And then address this means that we're creating the pool liquidity of the current contracts ERC20. And then you're just iterating through all the positions you want to create and minting those positions. Then there's like a couple hundred NFTs that are created that represent that liquidity position.
Exactly. Yeah, exactly. And for, the smoother the curve or the less liquidity positions you have, the less positions you need to create.
How is gas on this?
This is the beauty of L2s. The gas is actually quite cheap for us. We don't do hundreds of LP positions though. I think we maxed out at about 50 right now, which is it is quite expensive, but the best part about, building on L2s generally is the fact that gas is so cheap and we're able to do this pretty efficiently still.
So is it basically the fact that the constructor of the ERC20 contract itself is actually deploying the liquidity that makes it such that the ERC20 contract itself is the collector of the LP rewards?
Exactly. So we have
it's the initialize though, right? Because it's
initialize. Sorry, yeah.
Effectively, yeah. It calls the initialize function, which on initialization, deploys that liquidity position, and starts owning those LP positions. Once that token owns that LP position, automatically the trading fees are accruing to that token. They can be claimed by the creator.
It's actually like one more level of indirection, technically, right? Like, because it's like liquidity fees actually accumulate to the NFT position owned by the ERC20.
Oh, right.
And then you have to like claim out of the NFT. And so there's like, it's like if we draw the diagram in Figma, maybe we should because it's like a kind of crazy example of composability. It's like this ERC20 interacts with the market, deploys itself, and then the ERC20 owns the. Let's open the Figma and just draw this because
that'll be more fun. Let's do it.
Yeah. So we were saying you have this ERC20 token, and this token ends up owning these NFTs that represent a position of itself in a market. And then you claim the rewards from the NFT that's owned by the coin.
This is effectively what happens, right? So a coin factory deploys a coin. The coin reaches out to the Uniswap protocol and creates a Uniswap pool for that coin. When we're creating that pool, we create a whole bunch of LP positions. And those LP positions create these ERC 721s that are owned by the coin itself. What happens then is anytime a trade happens on the Uniswap pool, we have rewards flowing to the LP position actually being affected by that trade. So all of these rewards coming through the Uniswap pool go into these ERC 721s that can be claimed by the coin. It gets actually so much more deep than that, but I will leave it there for now. And that's effectively what's happening with these LP positions. All of these rewards are flowing through these 721 positions back into the coin itself.
So for the creator to be able to ultimately claim the LP rewards, do they have to take some action?
Fortunately, no. So I'll put another contract over here, which is the rewards contract. And then just for fun, we'll do one over here, which is Coinbase Smart Wallet. So when a trade happens on Zora, the buy happens through Uniswap, rewards flow to the ERC 721 token, the coin contract can claim those rewards at any time, and those rewards flow to this rewards contract. At Zora.co and on the Zora mobile app, we actually proxy all of our buys and sells through the coin contract directly. So rather than interact directly with the Uniswap pool, we call buy and sell on this contract directly. And what that does, and the reason we do that, is to add a hook after the trade has been completed. So every time a trade happens through the coin contract directly, in addition to having the trade execute on Uniswap pools, we also call claim on the ERC 721s that have been affected. So every time a trade happens through the coin contract directly, we're sweeping the funds out of these ERC 721s into the coin contract and then sending them to this contract called the rewards contract. And this rewards contract has existed forever on Zora. What's really nice, and like the way we kind of obscure this all for users, is this rewards contract is actually always called by the Coinbase Smart Wallet when you're generating user operations. So every user on Zora has something called the Coinbase Smart Wallet, which Coinbase created. And as part of the user ops, the very first thing we do is withdraw the rewards from the rewards contract. So you always have Ethereum available to use.
So anytime you perform any action in the smart wallet, you're claiming any funds that may exist for that user.
That's right. Anytime you have any action that requires some ETH, we pull out any rewards you may have outstanding. So there's like this constant flow of funds coming out of the rewards contract into your smart wallet. And then the end user experience there is actually quite simple. You just see that you have Ethereum always available, and you don't know under the hood, obviously, that we're doing this complex user op withdrawal before we do whatever action you're asking for. But that's kind of the beauty of these user ops, is that you can chain multiple complex transactions on top of one another.
And so you're like bundling a stack of user ops, and that's uniquely unlocked by smart wallets.
Exactly.
And the hook that does that's built into the coin contract, and not to be confused with a V4 Uniswap hook.
Exactly. So this was actually our way of getting around the fact that we didn't have Uniswap V4 hooks, was that we put the buy and sell directly onto the coin contract.
And that works because the entry point that the smart wallet actually hits is the coin contract when you do buy. And so you go through the full Uniswap flow, and then you have access again to like the context after the swap has been complete to perform actions because you're controlling the entry point to the market.
Exactly. And the hidden beauty there is even if other integrators don't interact directly with our coin contract and only interact with the Uniswap pool, the next transaction that happens on Zora.co or on the Zora mobile app will sweep those funds anyways. So there's an eventually kind of consistent rule that happens where, regardless of what's sitting in the Uniswap B3 pool at any time, as long as a transaction eventually happens on the coin contract, those funds are swept and put in the reverse contract.
It's a super interesting design. It's very elegant. And in like some ways, it also goes against all of these principles of like functional programming of like no side effects.
100%.
Right.
Yeah.
So like it's interesting that you're managing state in almost entirely through side effects in a way.
The no side effects rule almost doesn't work on Ethereum, given the fact that every transaction kind of creates this emission of new state machine states that have to be formed. It's almost like the nature of the way blockchain works is you're effectively always going to have that.
This is like smart contract designed by people who grew up writing React.
That's unfortunately quite accurate for me.
Cool. So kind of shifting gears to like more generally now, I think this is always a good question to ask a fellow engineering leader is right now, what are some of the biggest engineering challenges that Zora is facing?
I think like this comes with the territory of kind of always being in nascent development as crypto forever is how quickly it moves. I think for us, we have this core belief, like I kind of mentioned at the beginning, that all content has value. There's some non-zero value attached to every piece of content on the internet. And our job, or the reason that we kind of created Zora, is to try to reveal and capture that value and reward the creators that created that content, as well as the distributors that made that content propagate. Designing markets for content is very different than traditional marketplace designs for crypto generally, where the idea was to have very, very valuable scarce assets. We're working on like very, very abundant, low market cap assets. And that's a new territory for us to be in because it actually means that we don't want coins, for example, to start at the market cap of $2,000 or $3,000. We actually want coins to start at the market cap of near zero, because the reality is most content on the internet is probably closer to $0 than $1,000. And the market design for that is very, very intense because all of the infrastructure that we've been building on kind of assumes you're actually building for scarce content or scarce assets. It's a very fun technical challenge, but it is like the core or the crux of what we're trying to design and develop at Zora. So that's like the most fun and also the most challenging thing that we're working on right now is there will not just be, a small limited set of assets you can trade on the internet. Our bet is that actually everything has value, and we should be able to reveal that value and allow people to speculate and capture that value as well. In doing that, though, that means that the average price of everything comes down quite a bit, and designing markets for that behavior change how markets have been developed in the past.
That sounds super hard, and that is like the right curve answer of like this is the smart, takes gigabrains to like work out the math and figure out how to like move those economics. But like, what do your engineers spend the most of their time struggling with?
We kind of walked through it in that design session. There is a lot of crypto happening under the hood, and in order to make a consumer app that works, you need to obscure as much of that as possible. And that means that the engineering and the design teams at Zora need to have like a very good implicit understanding of what's happening under the hood such that we can obscure it and abstract that away. That is like a forever challenge for us, especially given how forward the tech is in crypto, but how far behind the design and the UX of crypto tends to be. It's a forever problem, and I think that's one that we don't escape. But the like hardest general problem for us is trying to obscure the intense technology that happens under the hood in something that's super smooth brain and easy to use without having to think about it. And the nature of doing that means that you do need to have this very in-depth understanding of what's happening under the hood, so you can see what you can abstract away and what you can simplify as often as possible.
And nuts to bolts, is that kind of like understanding, these backend processes are async, this part relies on a block confirmation, this relies on a transaction receipt or an event emitting, and sort of like knowing the entire sequence of that, but being able to cover it all up with like pretty pictures and UX, basically?
Exactly, yeah. Like, for example, a trade that happens, we don't have a exact confirmation of the... Well, let's talk about like a token swap that happens. If you want to put in 1 Ethereum into one of the pieces of content in Zora and get some amount of tokens out, the nature of the chain is that you actually don't know at the time of your transaction what the output will be in terms of tokens. So it's up to us basically to give a best estimate, and then within our UI or within our design, kind of explain if there was slippage, for example, or if the trade didn't execute because it was sandwiched, which fortunately doesn't happen on Base very much. But there is a game of cat and mouse basically on like what can we optimistically update versus what do we need to have designs for when things get rolled back or don't execute the way we expect them to.
Or even just like, has this actually been confirmed? And like, you know, have we indexed all the content? There's like a whole other aspect of Zora around like discovery, where like in some ways the trade page is like, it's complicated, but like you have the context, you have the transaction in the UI, and so you can like do some nice UI tricks because you get confirmation from the front end. But the discovery page at Zora was always like a tricky thing that we worked together to build out, because you have like all these traditional Web 2 systems that you need to build, like search and recommendation and ranking. But then you also have like, oh, we need to like index the blockchain and populate all that and get all the media and all the content and stuff like that.
Yeah, I think generally the aggregation of content is an extremely difficult challenge for us, especially when there can be different blockheads, for example, at any particular point in time, and we don't know what the true state is until a few seconds have already passed. So we end up with this very intense system of like what is actually the confirmed state of the chain versus what can we assume is the confirmed state of the chain.
Have the like Web 2 challenges of, creating essentially a content delivery app or UGC app, like have those proven to be relatively straightforward, or has that also been presented its own set of challenges?
I think it's presented its own set of challenges as well. And actually, I think Erik can speak to that more than I can.
Shout out Owen and the Zora team who work on this backend. But you have to kind of start from like, what is the data? Like with if you're Instagram, you have all the data in your database. But that's kind of true with Zora, but not necessarily true, because the source of truth is really the chain. And so you need to have like really good indexing that's like really low latency to be able to like say that in under a second or under 2 seconds something happened on chain, and then you can show it on in a UI like this. That's such a funny Vance. Like that little ticker at the top left there. Like I'm assuming, kind of knowing how Zora systems work, I'm assuming that is like the indexer firing a WebSocket into the front end in real time as things happen on chain. And that actually, like, to get that engineering down where you can pull from the chain, understand what's happening, and backlink like little preview images and like the number of tokens sold is really non-trivial work, because it requires like basically streaming infrastructure plus like high throughput databases plus like long connection polling or service end events to provide that like streaming update without polling. And so it is like, we've talked about this within CDP. It's like oftentimes right now building in Web3 is actually strictly harder than building in Web 2, because if you want to build a great product, you still need to do all the things you do in a great Web 2 product. But then there's all this other crypto stuff you have to layer on top. And so you really need to like have that value prop in crypto. And I think like part of our mission on CDP is like, how can we make it so that building in crypto is actually easier than building in Web 2? Because you have all this composability, right? You have all these like things that exist and are public goods and you can just leverage and they do stuff for you, like Tyson showed us. But how do you actually take all that and make it so building an experience like this is easier than it is on Instagram rather than harder?
Yeah, I think you've kind of touched on like the core superpower, right? It's the fact that if these primitives were made available to everyone in a way that's easy to consume and build on top of, you end up with a much more rich content network, or much more rich asset network, any type of network you want to build, because like we talked about kind of throughout this, everything's publicly available and can be built on at any time.
Yeah, and like someone could take Zora's contracts and write their own front end for it and build their own aggregation app, right? And that's actually complementary to Zora rather than competitive. It's like growing the network. It's like growing the network rather than competing for network share if they're bringing a new audience.
Exactly, and in fact, like the protocol itself explicitly rewards that. We've cut out a part of the capital flow that happens on those transactions for platforms that are integrating on top of the protocol as well.
The other thing that sort of resonated with me, Tyson, when you were talking about the financial engineering design difficulties and challenges, is like crypto really started off by putting capital markets on chain. And so they're all designed for, like, Uniswap itself was really designed for, it's an automated market maker. generally when we make markets, they're for things like equities or tokens or things that have fairly large amounts of financial value. At least that's like the mental model. And what you guys are really doing on is more akin to like micropayments or like really content markets. And I do think it does feel like, maybe this is just because ETH is at 1500 or whatever, but it does feel like that is a very strong direction in where the whole industry is trending, of like how can crypto facilitate large volumes of very small transactions as opposed to some amount of like large transactions. I do think like, and the engineering is sort of heading in that direction too.
Yeah, I think it's a kind of the path that it should go down, because I think that the net value of most transactions on the internet is actually quite small. That's not to say that they're not valuable, though, and I think that's a very important caveat with the design of these markets for content that have small starting market caps. Is I mean, I think we've quoted this about a million times in a million different places, but the general idea is that the right information at the right point in time actually has near infinite value, and we want to make sure you can capture all of that upside as well as that starting value. So you need to be able to build a market that can capture the entire range of value. Uh, Despite the fact that, yeah, I think most transactions on the internet probably end up being more akin to a microtransaction than a huge value transfer at any given point in time.
The example I give a lot of people is Jacob Horn, the CEO of Zora, last year created a meme of like a horse in like a angelic dream valley, like running with, I forget his original caption, but it became the like that feeling when and then like good feeling. And it went like super viral, and he had minted it on Zora, and like the market actually did kind of track the attention to some degree of like people. It got more mints because it got more like net attention on the internet, and it actually served as a pretty interesting proxy for like mimetic value versus like captured value. And I think Jacob has now minted and coined that horse in different forms. But I saw over the weekend the White House tweeted that horse.
What? Wait,
Yeah.
really? Wait,
Yeah.
can we bring that up?
We could try. Let's see if we can do it in real time. But like it's literally like this started out as literally a meme by Jacob, and then now it's like the U.S. government is like tweeting this meme, and that's the like power of like asymmetric upside of information on the internet. It's like things are just out there.
Generally, there is like this resonant value with all forms of content that can be captured, and like the horse was actually a really great case study in the fact that that's possible, because we got to track with the graph of market cap over time the actual spikes in attention it was receiving on the internet, and as more and more pieces of content are created, the market cap itself becomes like this really interesting feature, because not only does it inform people about what's valuable at any given point in time, it actually reinforces future generations of content that are being created, because you can track the patterns of market caps, and how attention flows through the internet more generally. So there's a whole bunch of really interesting things you can do when you're able to quantify the value of any piece of content. And the more you can reveal that, the more high quality content ends up becoming.
Wow, there it is.
My bad. It was the Department of Energy, not the
Oh, it was
White House,
DOE.
but
I mean, that's still pretty cool.
yeah, directionally correct.
Yeah. Anyway, so yeah, you had lolcats, and then you had Pepe the Frog, and then you had NFTs, but that was all mimetic around right-click save. But we've always had in our back of our minds like this latent sense that like there has to be a way of codifying and capturing value of these mimetic distributions. And it feels like on one hand, like, yeah, Zora's about creators and like helping creators monetize. But this specific vertical around memes on the internet does seem like a huge one that probably stands out on its own, which if Zora is successful at would be like massive on its own, which is very different from like the Instagram use case of like I'm a singer or I'm an artist that's trying to produce content. Like they're almost like two different worlds.
Yeah, and this is where maybe like the platform and the protocol start to diverge at some point, right? The protocol is designed to capture any form of content, whatever that happens to be, but it's very likely, obviously, that we'll have hyper-specific platforms on top of that with their own verticals. So there probably would be a YouTube style one for all of the best videos that you could capture, or purely a meme-based one, or purely a Instagram type platform. But that's, yeah, where we start to differentiate between like content and types of content, and you can even interact with both of those together.
What is the technology in crypto that you're the most bullish on?
I think the concise one that I'm generally excited about is Uniswap v4 and the extension of AMMs generally is showing there are more and more unique ways to capture different types of value that don't all need to have this one-size-fits-all solution. That's something that I'm very, very excited about because that allows all sorts of new market extensions to exist, from things like being able to get paid out in specific fees, using fees to extend liquidity. There's a number of different things you can do with these hooks, also known as side effects, that make very, very powerful markets.
The last question that we want to ask every guest is, if you were in charge of Coinbase Developer Platform, what would you build? Like, what could we build that maximally helps builders in the crypto space?
I think that something that Coinbase is uniquely good at that no one else has really figured out yet is actually the relationship it has with different governing agencies around the world. And I think actually there's a start of this with the Coinbase attestations work where you can reveal whether or not users are safe or not to interact with. But I actually think to have more and more mature markets, if we head in that direction, that would be something that's very nice to be able to leverage more as app builders in the space. Generally having to tiptoe around what is regulated versus what is not is very difficult for, I think, young startups especially to have to figure out. Having Coinbase as a shield or as a piece of infrastructure to build on top of, knowing that Coinbase has kind of handled that side of the building process for you would be huge. And I think that unlocks thousands of builders to be able to build whatever they want. That's something that I'm generally quite excited about if CDP starts to head in that direction. There's obviously things with Coinbase Smart Wallets that I think generally get quite exciting as well, where we kind of could replace something like OAuth with Coinbase Smart Wallets and sub accounts. But generally, I think the attestations around whether or not users are deemed safe in different regions or territories is something that could be quite interesting to see.
Tyson, really appreciated you hopping on and chatting with us.
Happy to jump in the weeds with everyone. That was fun.
It was a lot of fun. Thanks so much, Tyson. Lead the world's transition on chain by building with Coinbase Developer Platform. Visit us at cdp.coinbase.com. Follow us on X at Coinbase Dev, and be sure to leave us a review on your favorite podcast app.